Hi everyone, welcome. So we will be talking about OPEA and how we can accelerate that with a particular implementation. For those of you who attended to any other OPEA session, we have few sessions in the Open Source Summit. This will be specific for something great and that is a project or is an implementation using OPEA. So
let's start with the basics. What is OPEA? OPEA is an open source AI platform, a Next Foundation project that provides a common open platform for enterprise generative AI solutions. The idea is to avoid vendor locking. You can mix and match components from different vendors to build robust AI solutions. Its architectures is modular and composed of microservices for things like large language models, LLMs, embeddings, and the retrieval augmented generation, which is we call RAG workflows. In short, OPEA gives enterprises a flexible, interruptible AI stacks without trying you to a single provider.
Yes, and why enterprises? It's a project that is mainly oriented to enterprise. And when we talk about implementing GenAI applications on enterprises, they face some issues. We face the problem that the fragmentation issue, that there are too many tools out there, too many platforms, there's no way to identify one of them, or what is the best for the use case, what is the standardization, and there's no standardization, right? If you like to do RAG applications or GenAI applications, companies keep reinventing the wheel or trying to do the things with their way. The acceleration, enterprises want to have ready-made solutions because they would like to accelerate the go-to-market. So having something that can help them to implement those use cases very quickly and very fast will help. And also enterprise ready, the focus of enterprise. And when we are working with AI, we see that there is no enterprise most of the time. We just think on having something in a Jupyter notebook or in some place. It works, and that's it. But when we try to move that to enterprises, we need to worry about scalability, about security, about multiple things and that are applicable to the enterprise world. So that's mainly why we need some kind of solution or some kind of project to help on those deployments.
Before we dive deeper, let's introduce ourselves and how we are involved in OPEA. I'm Tsou, an OPEA Technical Steering Committee member for 2025 to 2026, and Director of External Tech Influence at TikTok. I've been championing OPEA in the community and helped initiate some key technical integrations into the platform.
And I am Lanza. I have two hats, the Intel hat. I'm open source AI evangelist. I have a DevRel position at Intel within the open ecosystem team. And I'm also the TAC chair and board member of the LFI and data. And this is why I didn't want to ask most of the questions. Even though the amount of projects, I was close enough. I didn't know the exact number. So I worked tons of years with evangelism around the world, creating content, videos. I'm not an influencer or YouTuber, but more like in terms of blogs and influencer part. And I work with open source communities most of my day, usually. So what is the synergy? When OPEA is based on cloud native concept, right, microservices, and we can guess that when we are working with those applications, they just work on the cloud. And it's fine. There are some use cases that you can actually work everything 100% in the cloud. But sometimes, in some use cases, it's very relevant to move this application to have something running on the edge. So let's suppose you have a kiosk or you have something. So this concept of edge to cloud or edge AI is something that's been out there for too many years. But now it's getting more adoption because there is a need to start using something on the edge. There's something on those borders. So this edge to cloud integration sometimes is not so easy to do because when we talk about those kind of GenAI end-to-end applications, how we can start splitting one part in the cloud, one part in the edge, and so on. So there is an enterprise impact too. So those solutions now has to be extended to those edge devices easily. So the project is integrated with, or this particular implementation is using InfiniEdge, which we'll be talking later, which is another open source project, part of the Linux Foundation Edge. And we were talking about why. And for instance, there is a use case, which is basically this example, which is what Sina was using. There is a demo that actually was using agents, and the agent was actually running on the edge device. So the entire application was running on the cloud, and she was running in the edge something that was doing speech recognition and was doing some interaction with her, and that was running in the edge. So we had an agent working in the edge, and it was a one-click deployment tool. So this is the benefit of Intel, OPEA, that gives you the one, I don't know why I say Intel. This gives you the one-click deployment. Has always this mindset, like, I don't want to have something very complicated or hard to use. I have something that is one-click deployment, one Docker Compose file, one Helm chart, something very simple to deploy.
To support the cloud-to-edge synergy, let's talk about Sphere, which is workstream 3 of InfiniEdgeAI. It is scalable and distributed AI agent platform. Sphere comes from the InfiniEdgeAI ecosystem and is designed to run AI agents across cloud and edge environments in a flexible, scalable way. Essentially, it allows multiple AI agents to work collaboratively and distribute their workloads. This is the key for complex enterprise AI workloads that might span from a data center cloud out to the edge devices. On the slide, you might see an architecture diagram of Sphere later. Think of it as the backbone that lets AI agents talk to each other and operate across different environments. In OPEA, we leverage Sphere to orchestrate these AI microservices and agents no matter where they are running.
Well, and now let's go. Hopefully you had lunch. I didn't have lunch because we didn't have boxes for us, but yeah. So this is the AI orchestration stack, right? So we have the lower bound when you have all the computing power, which is basically not one specific hardware. We have a heterogeneous amount of hardware, GPUs, CPUs, accelerators, and all of them available here. If we go above, the other layer is the model serving. When we are using LLMs or models, we need to use something to do the inference of those models. So we need to run this model serving. That could be VLLM, could be any TGI from Hugging Face, but that serving is actually taking advantage of the hardware. And that's a long conversation that you can talk about for hours about which hardware works better with which model, which is the optimization that you have to do. So that kind of things goes on the model serving. On top of that, we have the agents that are actually orchestrating, right, all the tasks that we have underneath. And in the top one, we have the developers and the users that they actually consume all of those things all together, right? So I would like to consume one of these. No, but yeah, there's another one.
However, each of these layers comes with its own pain point, which OPEA is addressing. For computing power, a big challenge is supporting all the different hardware out there, GPUs, TPUs, edge devices, without a ton of customer effort. In the model serving layer, the pain point is making sure models make the best use of that hardware. You don't want the idle accelerators or bottlenecks. At the AI agent layer, we run into issues with the speed requirements. Some AI tasks need to happen fast, and historically, a lot of agent frameworks have been heavyweight and tightly coupled to specific infrastructure or model details. Things like scheduling AI tasks across systems were pretty ad hoc. And for the developers and users, One pain point is programming language support. Many AI tools only support Python, and which can be limiting. And another is making interaction easier, so external systems or users can interact with AI in more natural ways. These pain points are exactly why OPEA is focusing on the AI agent layer and the dev and user layer first. By solving issues at these layers, we make the whole stack much more usable and efficient for enterprise developers.
Yeah, so now let's synchro back now with the projects that are being used in this example. One is InfiniEdgeAI and Sphere. InfiniEdge is as I mentioned, is a project. It's part of the LF Edge. There's multiple work streams. The main goal of this project is to talk about, or to cover edge computing topics or problems and try to solve most of them. And they have multiple work streams. One of the work streams is Sphere, which is actually something to orchestrate how those AI agents work. And it focuses on how you can distribute AI agents in the edge. So the main goal, or what is great of this, is that OPEA or LFI and data projects, they are focused on AI, of course, and how you train or your inference. LF Edge, this project were born with the edge concept in mind. So trying to have this synergy between how you can use something in AI that is very applicable and how you can use it in the edge, that's the main effort, and this is why it's great to start mixing, because the edge expertise with the AI expertise, and this is mainly the goal of this implementation.
Speaking of the version 1.2, let's summarize what was new in the Sphere release 1.2 and how it benefits OPEA. The team knocked out a bunch of improvements. First, they resolved all the previously failing test cases, so the platform is a lot more stable now. They also integrated LM API, which is an open source alternative for certain AI services. More on that in a moment. They categorized the agent tools into 3 types, making it easier for the system to handle different kinds of tools uniformly. And notably, they switched the data handling to use the flat butters to serializations instead of manual or gRPC-based methods. That change improves performance and makes multi-language support easier. I'll detail that in a minute. Overall, these updates also brought tool calling improvements and generally reliability boosts. So OPEA integrating Sphere 1.2 means a more robust, faster platform for all of us.
Yeah, we can go deep on this part, but this is probably more important to talk when one of the goals that when we talk about those examples is to accelerate how the inference or how the data is moved. And one of those improvements is change to the data serialization to use flat buffers, which basically, if you're not familiar with that concept, is instead of downloading the data and downloading, creating, and capturing those data, you are just using, let's say, everything on the fly. So you're not copying the data from one side to another side. But using that concept, when you are working with agents or with LLM, it accelerates a lot how the inference is done. So this is one of the main benefits. And this is why in the example, it runs faster compared, because that change is actually a good key for that.
Another big enhancement in Sphere 1.2 was the LM integration. LM is an open source AI API that designed to be compatible with the OpenAI API format. We plugged LM into OPEA as a way to give enterprises an open, self-hostable alternative for certain generative AI capabilities. In our initial integration tests, LM showed impressive results. It was able to handle requests similarly to the OpenAI backend in many cases. There is a caveat, though. We found that the host core support in LM isn't usable yet due to a known issue. We've noted the GitHub issue on the slide for those who are interested. The bottom line is with LM, OPEA can incorporate the cutting-edge open source AI models easily, which is a huge win for flexibility.
Do you want to show the demo? Because we have 5 minutes.
But we eat Todd is 20 minutes, don't we?
With?
Yeah, because Todd is not here, so we eat his time.
I think the sign is clear.
Okay. All right.
This part.
This neurodivergent companion is researched and developed by Hashan Japper. A special thanks to InfiniEdgeAI project, OPEA, COS, Furiosa AI, and Intel for their collaboration resources, expert input, and time. Here's the demo.
Okay. There's no audio? We need an audio?
Yeah, see, we got the multimodal, like the speech and the video, and the teddy bear is learning from the human being. It's for the autism, the children.
No.
Yeah, I think.
Move to now?
Yeah. Okay, so this is the architecture we have. You can see it goes, this is our vision report. You can get it, and it goes through the OPEA and the InfiniEdge processing and comes with the expressions. So the physical part components can understand and let the teddy bear to speak or make those faces and to comfort the autism children. Yeah, this is the part I was talking about. You see, we have the camera and the speech receivers, and goes through the chipset made by Intel and Furiosa AI, and some of the runtime processing in the InfiniEdgeAI, and running on the platform of OPEA. All the way goes to the cloud, and necessary for the codes to do the AI agent platform and deal with the workflows. So it's an end-to-end showcase how we do this meaningful use cases, bring the impact to the real life.
It was in a different order, yeah.
Yeah, I already presented
that
this
was
one.
on the other side.
Okay.
We go with this, yeah. Yeah, so the main goal, and it's something from the ALF that we'll be talking later, is how the projects start to integrate together. So we would like to avoid even the projects and also the developers and the enterprise avoid reinventing the wheel. There are tons of projects out there. There are tons of projects that are not part of the Linux Foundation. There are tons of projects that are part of the Linux Foundation. We don't even know what is out there. So try to find the synergy to say, hey, we have a great project, which is InfiniEdge. Let's mix it with OPEA, and let's try to do a joint thing together to solve a use case, right? So this is a great joint effort. It was with TikTok too, right? Creating this example and using the Live Studio. I don't know if I'm missing something here, or it's just fine.
Yeah, just fine.
Cool.
Beyond building technology, OPEA is about building a community. Let's talk about outreach and impact. At TikTok, I've been hosting developer meetups and even ran a tech workshop at Berkeley, UC Berkeley, all to introduce OPEA to new contributors and get more folks involved. we've seen a lot of excitement from developers who want an open platform for AI. We've also engaged directly with enterprises through webinars, community days, and collaborative working groups, bringing in everyone from startups to Fortune 500 companies to share their needs and feedback.
Yeah, we also see that, I've been presenting in multiple conferences and events. We see that it solves a need. That's something that is not solved on that end-to-end. There are multiple projects that solve particular parts, optimizations of LLMs or something particular, but there is no project that is covering the end-to-end from the UI until the inference. So trying to identify that, and that's something that when we showcase in enterprise engagements or communities or webinars or whatever, or even with developers. I used to do a lot of workshops with developers. It has a lot of interest. So yeah, that's yours.
Now, looking ahead, our collaborative vision and next steps. We like to say our vision is enterprise AI for all, making AI development accessible, flexible, and open for everyone. That's the ethos of OPEA.
We'll have a great roadmap. I will be presenting probably in 2 hours, I think, at 4. The Lightning talk that talks about the roadmap, what is next, and what is the project focusing. So if you'd like to be involved, contribute to the code, use case, ideas. This is an open source project, right? So even though it was donated by the Linux Foundation by Intel 1 year ago, it's part of the Linux Foundation. So you can contribute code, use cases, ideas. Some people contributed, for instance, a finance use case, but that's the main idea. So just to make a broad example.
To wrap up, thank you all for your time and enthusiasm for today. We encourage you to get involved, try our OPEA on GitHub, join our Slack community, participate in our working groups, and come to our next community call. I also want to give a shout out to some of our colleagues for their contributions behind the scenes. Alex, Malini, Roy, Wilson, and help make OPEA all it is.
Thank you so much. Thank you so much for your time. And we have some questions if you want. So thank you.
Okay, so big round of applause for our presenters.